Guys, my name is Volodymyr Tsap and I'm Chief Technical Officer at Tsap. And today we'll speak about infrastructure readiness, and that's something that you can name this infrastructure to be production ready. I guess everyone from you this infrastructure in place, but before we start, I let me tell a few words about where we now. We are at DevOps Stage 2022. Unfortunately, this is like offline, online event, and we can't be present in person due to the conditions that happens in our country because of the Russian bastards that we're trying to fight against them. And I believe at 100% that our country would be free and healthy and wealthy, and next year we'll be sitting around on a large conference and chatting about infrastructures and having a good time. For today, quick introduction about myself, what I'm actually doing these 20 years in a row. I first started my open source journey and started that at 2002. It was like 20 years ago. And since then, last 12 years, I'm running a company that actually building infrastructures, adopting customers' infrastructures, planning, architecturing, and things like that. And we come to the conclusion that not all environments, infrastructures are equally ready to be named as production-ready infrastructures. Yeah, so some of them are on the legacy stage, some of them are like trying to start something new, and we need to somehow grade that based on the organizational structures, based on the things that are happening during the infrastructure development, CICD process, engineers that are involved into the processes. And like to measure that, we create some survey that potentially we include points that are useful for everyone who'd like to understand how mature is the infrastructure that he actually working with. So let's start, and it's 12 questions. First 4 questions based on the DORA Matrix report, this global worldwide survey passed by a lot of companies, and we believe that this is very good approach to understand the K for DevOps Matrix. And we also include that at our local report, our survey, because that's something where we can measure how competitive, how far away or how close to the elite performance, so-called companies that are have the very good engineering culture, great infrastructures, everything is pretty well, and how they can prove that is based on that reports. So the first things that is one of the key DevOps metrics is the deployment frequency. So this metric is about how often your company could release new changes, and it's not only about product changes, but also into the infrastructure changes. And the best thing to do that, let's say anytime. Yeah, so if you are able to produce your changes anytime you want, let's say Friday night when everybody sleep and some developer try to push new version of code because he wants, and if he able to do that, and that is not something critical to the production system, That's pretty cool. And so that's the first step, that you can rate your infrastructure about how frequent and how often you can implement changes. And if that part is automated, if that everything is tested, it is quite safe. And this enhances the company ability to have quick time to market. Second thing is the lead time for changes. So basically, this metric means how much time you need to spend from your code commit, and this code commit, this change actually hits the production. Sometimes we have obstacles that are far away from our direct responsibilities. Let's say we have some security department that needs to review everything. We have some automatic testing frameworks, or we have system that is highly monolith and you can't produce any changes because that could impact some other parts, and you need to have some extensional integrational testing, and that increase that time. So if you can do that under less than 1 day, it's a good point. So it won't take you so much time, and it's a bit correlated with the first metric. And I guess that also are things that have a big impact into the business directly. The next thing is the change failure rate. If we push something to our production system, how often something breaks down. Yeah, so remember that guy who tried to push new release on Friday night, and how often that fails, and everyone wakes up and say, oh, we have a problem, we need to do something, and that's something bad. Definitely. So I think that if you are able to cover whole points with the testing, cover with not only smoke tests, integrational tests, and you are able to understand where that potential change could lead to critical failure, then I in good pace. So if that happens less than 15% whole the time, that means that I'm in a good fit and your change failure rate is optimal. The next thing is the mean time to recover. So that's something is very, very important because that leads not only cover not only the fact that you are able to recover, but the fact how quickly you can identify that you need to be recovered, that you actually have that backups, that you have notifications, that you have documentation that contains the procedures that you need to in different cases, and that we would extend that points in our further topics. But meantime, to recover, try to keep that as less as you can, because this is about business continuously. You can make this, test this, and be sure that you are able to recover very quickly. Okay, let's go next. And that part, for now, we have finished with that Google DORA report, how they perform that. I guess that's great framework. You can download that surveys and compare to your competitors. But we add some additional things that we believe are very important to grade your infrastructure at all. So the first thing is the infrastructure as a code. So this, for our experience, is one of the key metrics on how you can recover your infrastructure, because you have full copy of your infrastructure description. You are using some cloud stuff like Terraform or Pulumi or any CDKs, and if your infrastructure are completely in code and you can spin it out in minutes and you can track your changes because that's everything is inside your repo, and you are able to validate and review your changes for the infrastructure. You can act like the same way how developers work. So when they create pull requests, they can review that pull request and then apply that. And the next level of that is the GitOps. That is just modern way to apply changes because you are working with Git directly, and when you change something, your Git system get that update, and your controller within your cluster or within your any other infrastructure controller could go pull that changes and apply them inside your infrastructure. That keeps very little space to get the configuration drift. Configuration drift is when you don't, your actual declaration of your infrastructure is not is not in actual state. So if you are using GitOps, that obviously would lead for better coverage and less configuration drift for your infrastructure, and that's something optional, but we believe that that is a good thing to have in place. So if you have problems that you have no infrastructure code, that's first thing you need to consider to implement. That's very important, believe me. Thing that I'm asking for new customers, for new infrastructure, is do you have any code for that? That's very important, believe me. Thing is how you deliver your applications, how you deliver at what manner, what is that, what is the artifact that you can build. And we are living in the time where we try to build cloud native infrastructure. So everything is cloud native, everything is running on top of containers, orchestration of that containers, like with Kubernetes. We have this large space of cloud native world. Definitely you can go through CNCF landscape and see how many tools are on top of that. And actually, it's very important that it's give you ability to transport your applications, your infrastructure stuff from one cloud to another. You are able to test this on your local machine and literally could replicate everything you have in production into your local machine or development environment. And that's something is very nice to have. So if you actually don't have any containerization, that's something you should think about. And you can go another routes. So it's possible if you use Lambdas, for example, or use some services like Heroku. But at nutshell, it's about containers. I mean, not only Docker, but the manner how you are able to push and propagate your artifacts, and how you are able to test that from one environment to another. The next thing, I guess it's something interesting because we have that stack modernity. We have that revolution, as I said, cloud native revolution. All technologies are spinning, and we have like JavaScript guys, new framework each day. We have new technology that could be considered to be adopted, but that doesn't mean a lot. That means that you should follow at least some most common ways to do the things. I guess we shifting from one level to another. At first, we running our code and upload it through FTP to our to our physical servers. Then we have like this physical servers provisioned with Puppet, Chef, and so on. It was like 12, 15 years ago, or 10 even. Then we got that cloud ability to provide our virtual machines. Then we get Docker, we got Kubernetes, and that tells us about that evolution and stack modernity. Yeah, definitely we have some most common technologies like Kubernetes and Terraform right now, and I think it's very nice to use them. Maybe you can check what is on your radar. Possibly that could be some things that you can describe infrastructure with, or adopt some new approaches. Let's say if we are talking about infrastructure as a code, you can evaluate things like CDK, Pulumi, or Crossplane, but don't hurry up about that. I believe the best things that we have is if it's working, don't touch that. Don't touch that until you understand that this is something outdated. CICD is the next 8th point. So what about CICD? We have multiple choices for that. So at first, your CICD needs to be able to provide to deploy artifacts to multiple development and production environments the same way. Yeah. So if you follow the same approach, you are able to keep the same artifacts to be published into your development and production infrastructure. Also, we can use something very modern, and everyone tries to implement that in elite companies, something that's called progressive delivery, when you can matter during the CI/CD, during the deployment, how your application behave inside the production environment. You can calculate how many failures do you have. You can produce some canary releases, and then matter how much failures do you have, and then make the decision to go further and promote the new version into your production environment. So that techniques that actually reflects the actual state of the new version, and it's automatically, automagically done. It's about progressive delivery, and a lot of things are working around the space inside technology. We have service mesh interfaces that allows you to interact with your controllers, that could interact with your monitoring system like Prometheus, and then based on the metrics that you receive from your, for example, logs or other queues, you can make the decision to enhance, to promote more to the new version. And it's something very nice to have in our environment. And the promotion itself is very important. So that if you are able to promote not only one artifact to the target infrastructure, but let's say you are able to test, to perform that integrational testing on your staging environment, and be sure that all version of your services, if let's say if you have 20 services and you make some changes into one, you need to be sure that you have the test for the whole set of that services, and then you can promote that bunch to the production environment. And something this is something very important if you believe that you need to have a good testing before going to the production and showing this new version to your customers. And continue with CI/CD. Definitely you should have some code reviews. Possibly you can use new techniques like decouple CI and from CD. Maybe you can go with the approaches where you can perform infrastructure testing. That's something is very tricky thing right now. That part when we try to understand if that mature enough, if you have that fancy things like progressive delivery, if you test your infrastructure, if you fully go through this change management, through the process where you apply your changes only after being reviewed and tested, that means that your infrastructure is cool at that. And let's go to the security stuff. It's interesting because there are so many things that you need to think about security inside your infrastructure, because you have so much tools, so much policies, users, permissions, and you need to keep that in your mind constantly. You need to be sure that your infrastructure is tested by someone or inside your company. The perfect thing if you have in-house security officers that are responsible. A larger organization could afford like blue, red teams that constantly try to break something, and another team try to detect that activities. It's very cool if you're using web firewalls, intrusion detection, intrusion protection systems. If you are like able to protect from DDoS attacks. And if you are 100% sure that the build you produce, for example, in your CICD system, are signed and it's really the same code that works, that came from your CICD system, actually work on your production environment. So we have active security, passive security, security practices like risk assessment. So when you gather with your team and decide, okay, what would be most important things for business if we for example, leak the data or get hacked and our like bank accounts got leaked and someone get our money from that. Solve that techniques like rapid risk assessment. There are a few frameworks. If you follow that rules and you at least know about them, try to dig into and make sure that you are securing the things with the correct priorities. Because if you have like open secrets, it doesn't matter that you can protect the things that like good access to that secrets, like your code. So yeah, so don't just assume that you already hacked and what this security issue could like get into like wide range of problems and how you will address that problems. If you have ability to restore from complete deface, we have like situation where we need to restore complete site, complete infrastructure, databases, because we have that copies. It's also part of security that you need to think about. And we prepare some questions that could point you to the things that are important and possibly consider to use as your security practices. And that means that your infrastructure secure enough, and that means it's mature enough to work with real customer data. Okay, let's go next. And as I said, the infrastructure is not the production infrastructure without two things, without backups and without observability, without monitoring. And let's talk about backups. There are two kinds of people, who are doing backups and who will do backups. Yeah, so that means that definitely if you have any problems at that space, that something will shoot you at your leg at some time, definitely. So if you're good at that space, that means that you regularly test the backups, and you have disaster recovery plan, how you can recover from that backups, and you have like engineers who are trained to restore from those backups, and they do that constantly, and like one time per month they try to restore whole infrastructure and check if that doable and if that data is correct and you have the correct backups, and if you are able to automate that, that's cool, but be sure that this your tests, backup tests, are automated as well if you automate the whole process for that. Infrastructure as a code particularly allows you to back up your at least declaration of your infrastructure. So as I said, if you don't have any configuration drift, if you don't have any manual changes, that would help you a lot to have this good backup for at least for the declaration of your infrastructure, that you can replay and spin at least infrastructure. Then you can cover the backups for your databases, for your files, etc. But it's also nice to have. The next step is the observability. Observability, that means logs, metrics, traces, and alerts. There are a few ways at first. The common problem is when you don't have any centralized observability system and your developers try to go to the kubectl and check logs via this command line, and they have like bunch of instances, and how can I go through this information? It's completely useless. So the first thing you need to be sure that you have is that you have your centralized logging, alerting, monitoring, that you cover all metrics that is really useful for your environment, and you got something on top of that to alert like right people at right time about any issues. It's like Lens that you can see your infrastructure, and if it's something is not pretty well configured, you can be bothered about monitoring system but if you do that right and correct, your developers will be happy because they have centralized monitoring system, centralized logging. Your infrastructure engineers will sleep well and work well because of that. And if the failure happens, make sure that you have some post-mortem analysis procedures, why that happened, how we can prevent that from that being happen next time. And that's something useful that you need to have. Point at to our like basket things nice to have and great to have if you have mature infrastructure. There could be service level objectives, service level agreement, this SLO, SLIs, pretty cool framework. I think that it's not mandatory, but nice to have, well as self-healing things. So if you're designing your observability system, then you need to understand if that part could somehow self-heal or not. And the point that is not included here, but don't forget about that, you need to monitor your billing. That's something is very important, because if you're working in cloud provider and you spend a lot of money and you forget to like close or delete your 100 clusters, or someone mined bitcoins inside your cloud account, you need to be alerted as soon as possible, because this leads to like direct money failures. So make sure that monitoring covers that billing things as well. And last but not the least thing, if you have documentation Documentation is very crucial thing from my experience, because if you adopt something that completely without any instructions, you need to dig a lot and spend a lot of time to understand what is inside this infrastructure, why they perform that changes, why they create this stuff. Sometimes you think that, okay, how my previous guys who worked with that infrastructure can do that thing, and why they did it. And you can go into the documentation, into the change notes, and see that decision were made because of, for example, they don't have engineers enough that understand that particular stack or technology, or they calculate the cost of that decision and solution. So I try to track not only the observability and bird view of the infrastructure, but the changes and the reason for those changes, why they are being applied, and the overall system design. So I could include also the onboarding documentation. So if you're expanding your engineering department and you got like 5 guys per year, and they are completely new, you need to spend time with each of them and explain what's happening around. It's much better if you have this introducing documentation, this bootstrapping guide, what you need to learn, what you need to know, where is access located, or something, other important things are located, and who is here in that team, and what is the responsibilities. And I can say that's nice to have, for example, in-house stage writer that could lead those things and help you with creating some extensible documentation. And this stuff is also a very valuable part that you can add to your infrastructure to be mature enough. And that's it. I just explained a quick set of the steps we can go through and check if that something that you have in place. And but that's just my opinion, and I guess there could be some changes, and but the main point that I can actually want to show that some point take the step back and look around, check what are you doing, what the reason for those changes, for those efforts, why you are creating that infrastructures, or you're implementing some new tool that would impact the business processes, how that would help other guys to save time and money, and try to revisit every time. So what I miss, what needs to be done, and anybody could go with that initiative that, okay guys, I just checked and we don't have DR plans, let's make them. And it's we think that this is the priority for our team, or we need to implement some security scanners to be sure that the software that we are deploying into our production system has no issues, and so on. So let's try to force that initiative and try to convince everybody that that points that is critical they really needs to be implemented. And if everybody on the same page, the team, you will get highly scalable, highly resilient, and very effective infrastructure, and you will be happy, and yes, your teammates will be happy, and everyone who uses your service will be happy as well. Okay, that's it. Thank you, guys. Thank you, DevOps Stage, and I hope that we will see each other in person in 1 year. Welcome from Ukraine, from Kyiv, and have a great day. Bye-bye.